Hello everyone. You remember last class we talked about this thing called independent events. Today we're going to be talking about dependent events. So remember that independent events, where when we have things going on that does not, each event has no effect on the other event. And we said, for example, rolling a dice. If you roll a dice and you roll a 3, pick up the dice and roll it again, that just because you rolled a 3 has no effect on what you're going to roll. Again, okay, dependent events are the exact opposite. These are events where the first event does have an effect on the second event. Okay, so let's write down a definition first, and then we will. I don't know why my thing does that. It's weird. Okay, so let's write down a definition first before we do anything else. Okay, so dependent events. What are dependent events? Okay, well, they occur when one event has an effect on another event. Okay? So dependent events, you can tell if you have dependent events if your first event has an effect on the second event. Let's think of some examples. Let's say I had I was going to say a deck of cards, but some of you aren't familiar with decks of cards. So let's say I have a stack of collector cards of some sort, like Pokemon cards or something. Okay, let's say that I have 10 cards. Okay, I have 10 cards. Let's make up some numbers. Let's say that 4 of them are, I don't know, how am I going to divide these up? Let's just do simple cards. Let's just say that 4 of my 10 cards are red. Okay. Let's say that 3 of the cards are blue, and 3 more of the cards are green. So 4 and 3 are 7, 7 and 3 are 10 total cards, 4 of them are red, 3 are blue, 3 are green. So here we would have dependent events. Let's just do this scenario. You're going to choose a card. You're going to choose a card at random. And you're going to keep the card. So you're going to take this deck of 10 cards. You can't look at the cards, or you can't see the face side of the cards. You're going to randomly pick one and you're going to keep it. Then you're going to choose another card. So let's say that what you're really after, let's just make up a scenario. Let's pretend we want to ask, what is the probability that you get, let's just pretend maybe it's the blue cards are the ones that are really awesome, okay? What's the probability that you get 2 blue cards? And if we work through this will demonstrate how we have dependent events here. Okay, and then I'll give you like the formula with letters after. But what we're going to do is we're going to work through this first and just think about what happens here. Okay, so on the first pick, on my first pick of a card, I'm going to pick a card first. Now we're trying to get 2 blue cards. Let's just start out. What's the probability on my first pick that I get a blue card? Well, that's easy. Everyone should know how to do that real easy, because that's just simple probability. It's the first thing we did. Just simply, there are 3 blue cards in a deck of 10, so you have a 3 in 10 chance of getting a blue card. Now, when we go to make the second pick, this is where you have to stop and slow down and think about this. So remember, the question says that we keep the card. We've taken one of these blue cards and we're not putting it back in the deck. So there is no longer 3 cards in there, 3 blue. We're going to pretend that we got the blue card on the first one. So in this scenario, after our pick, you have to think about that now we only have 2 blue cards. No longer 3. There's 2, which means we don't have 10 cards. We actually have 9 cards now because we've taken a blue one and it's gone. So on the second pick, if we did the same thing, what's the probability of getting a blue card on the second pick? So we have to watch this. So now there's only 2 blue cards out of 9 cards left. So on the second pick, we have a 2 in 9 chance. Now, just like independent events, if we want to know what the chance of the first one happening and the second one happening at the same time, we're going to multiply these two numbers together. So we're going to multiply 3/10 times 2/9. And you remember when you have fractions, you just multiply the numerators. 3 times 2 is 6. 10 times 9 is 90. So you have a 6 in 90 chance. Now you could reduce that fraction, but I'm not so worried about if you can reduce the fraction. If it's probability, we probably want a percentage anyway. So just take your calculator and just say 6 divided by 90. And you'll see that in the calculator, it gives you this. It tells you 0.0 and then repeating 6. Okay, repeating 6. So to get that as a percentage, so we can actually say the percent chance that this happens, you remember we just multiply it by 100 or move it 2 spots, and we get about a 6 point, we'll round it, 7%. So there's about a 6.7% chance that in this scenario you would get 2 blue cards. Now let me give you the formula and then we'll do another example to make sure that you really get this. So let me clear this. Okay, so the actual mathematical formula. So here's your formula for dependent events. So just to recap, let's write them both down again. You'll remember that independent look like this. Independent. So independent events, and your formula I said look like this. The probability of, and we said event A and event B, we said was equal to, you would take the probability of the first event and you would multiply it by the probability of the second event. Now you're not limited to 2 events. You could have probability of A and B and C and D and E and so on. This is no limit to how many times you could do this. You just multiply them all together. That was independent. Now let's see how dependent's different. So your formula for dependent looks a little bit different. This is the way we would write it. So if we're talking about dependent events, in the case where we're saying the probability of the first event happening and the second event happening, you'll notice that this looks exactly the same so far. So far it looks exactly the same as independent events. This is where you have to distinguish whether you have independent or dependent events. And this is going to change on the next part. So if you have dependent events, when you go to figure this out, you're actually going to do this. You're going to do the probability of A, so the probability of the first event, and you're still going to multiply. You're going to multiply, but here's where it's different. This is where you write it. The probability of B happening, but then we put this straight up and down line right here. Straight up and down line, and this means given. Okay, this line, when we read this, this means given. Okay, given A. So the way we would read this, from left to right, okay? So if it's dependent events, we would say the probability of A and B happening is the probability of A happening times the probability of B given A. So that's sort of like this here. That's sort of like, okay, well, we had 10 cards, but given that we got A, that we got what we wanted on the first thing, so given that this event happened, B is altered given by what happened here. So in other words, if we had like our 10 cards, now we only have 9, that type of thing. Okay? So let's work through this. Let's see, let's make up a scenario. Let's say that we have a bag of marbles here, okay? So I've got this bag of marbles, and inside the bag I have, let's say I've got 3 red marbles. 1, 2, 3. Okay, I have 3 red marbles, and I've got 2 green marbles. 1, 2, And let's say I have, do we want to throw something else in? No, that's good. That's good for the purpose of what we want to do. Okay, so I got a bag of marbles here. 3 of them are red, 2 of them are green. So what I'm going to do is I'm going to, here's the instructions. You're going to choose a marble. Well, you're not going to choose. You have to pretend it's like a blind, like you can't see in the bag. You're going to reach your hand in and grab one at random. You don't know what you're getting, but you're going to choose a marble and you're going to keep it. You're going to keep the marble. Okay, then you're going to choose another marble and keep it. So, in other words, when you're doing probabilities, it's very important to pay attention to the scenario and what's happening because you have to figure out which one is going on. Do I have independent events or do I have dependent events? That's something you're going to have to figure out. All right, so let's answer some questions. Let's figure out, how about A? Let's figure out the chance that both are green. What's the probability that, given this, I follow these instructions, what's the probability that I actually get the two green marbles? Okay, so our formula is going to be like this. The probability of getting a green marble, and getting another green marble. I'm trying to figure out how to, and getting another green marble. I guess I didn't really need to put these in parentheses. I kind of wrote that weird, didn't I? Okay, so what's the probability of getting a green marble and another green marble? So if we follow our formula, we know that we have to think about, is this dependent events? Well, yes, because we're going to keep the marble. We're going to choose a marble, take it out of the bag, meaning there'll be one less in there. So that will have an effect on my second choice. Therefore, it's a dependent there. These are dependent events. So I have to adjust the odds on the second pick. So my formula looks like this. This will be the probability of green multiplied by the probability of green, but given that I got green on the first pick. Okay? That I actually got the green marble on the first pick, and I'll have to adjust the odds on the second pick to figure it out. Okay, well the first one's always easy because nothing changes on the first one, right? What's the probability of getting a green marble? Well, there's 1, 2, 3, 4, 5 marbles in the bag, and 2 of them, 2 are green out of the 5. So I have a 2 in 5 chance of picking a green marble. So when you're doing these formulas, you're going to assume that you got what you wanted on your first pick. You're going to assume it went right and you actually did get a green marble on the first pick. So when we do the second one, this is where we have to be careful. Okay, well there was 5 marbles. How many are left now if we keep the green one? 4. There's now only 4 marbles. How many? Now remember, we've taken one of the green marbles out. So when you're doing this, you want to actually, like, put an X over it or something, or do something to show that one of them's gone. So we actually did take one out. There's only one green marble left at this point. So now instead of a 2 out of 5 chance on my second pick, I only have a 1 in 4 chance. So let's see what that works out to. 2 times 1 is 2, and 5 times 4 is 20, right? Now, like I said, I'm not so worried that you can reduce fractions. I mean, this one's easy. Look at that's 1/10. Okay, but if just mash in your calculator and get the percentage. That's what I'm after. Well, if it's 1 in 10, that is a 10% chance. So you have a 10% chance of getting 2 green marbles. Let's try another question. How about B? How about what's the chance that both are red? Now, before we even answer this question, let's just think about, do you think that your chances of getting 2 red are higher or lesser than getting 2 green? What do you think? You think about that for a second before we do it. Do you think that you have a higher chance of getting red, and why would you? Or do you have a lower chance of getting 2 red, and why would that be? Okay, so let's work it out and find out if you're right, whatever choice you pick there. All right, so both are red would mean I would have to do the probability of, let's write it. I messed it up on that first one. Let's write it properly this time. So we want to know the probability of getting red and, remember this symbol for and another red. So we're looking for the probability of R and R. Well, that's going to be equal to the probability of getting a red. Actually, let's just, you've already written this down because you're just taking notes on your own. Let me just clear this up so we got space here. And we'll just remember that our answer for this one was 10% because we want to compare. So probability of red multiplied by the probability of getting another red given that we got red on the first one. So that's going to be the probability of getting a red marble. Well, there's 3 red marbles out of the 5 total. And we're going to multiply that by the probability of getting another red given that we had red on the first one. So given that we got red on the first one, that means we no longer have 3 red marbles, we only have 2 red marbles. And instead of there being 5 marbles, now there's only 4. And let's see what that is. 3 times 2 is 6. 5 times 4 is 20. So 6/20ths. Okay, and you could reduce that. I'm not worried about that you reduce it. Just mash it into your calculator. So just take your calculator, say 6 divided by 20, and get a percentage. So that tells me 0.3 in my calculator, which I know means 30%. So you can see you have a much better chance of getting 2 reds than getting 2 greens. And that makes sense because there are more red marbles in the bag. Okay, let's do a couple other questions. Let me clean this up. We're going to do a couple other. Oh, I don't want to clean. I don't want to erase it. Let's just do a couple more. We'll do 2 more as an example. Okay, what about, so this would be C. What about, what's the chance that both are different? This is going to be a difficult question. What's the chance that both are different? This one's going to be much more difficult, isn't it? The reason why this is going to be more difficult is because, is there more than one way to get 2 different marbles? Or is there only one way? Do I have to choose a red first, then get the green? Or could I get the green first and then the red? They'd both be different, right? Okay, so I'm going to have to think about how am I going to go about solving this? Should I draw a tree? Should I do a tree diagram? Should I do Should I do a tree diagram? Or should I just calculate the odds each way? Like okay, let's get the red first, then the green, and then let's figure out, well, what about if you get the green first, then the red? Okay, either way is valid. Okay, either way, you could do it either way. You could draw the tree diagram out, put your different combinations and all that, but I think you're smart enough. Let's just figure it out. But you have to realize that there's more than one way to get 2 different colored marbles. So the first way that I can think of that happening would simply be, let's pretend we get the red marble first. So probability of red. Okay, oh, well, let's do it wait. I don't want to mess you all up here. Let's do it. We're going to do probability of red and then getting a green. Okay, so probability of getting a red and getting a green. And remember, these are dependent events, so that's going to be the probability of getting a red multiplied by the probability of getting a green given that you picked red on the first one. So probability of getting a red, as you know, there's 3 red marbles out of 5 total, times, now, what's the probability of picking a green given that we got red on the first one? Okay, well, we didn't touch the reds on the first pick, did we? So both green marbles are still there. There are still 2 green marbles. However, what did change is that we actually took one of the reds out of the bag, So there's not 5 marbles, there's 4 marbles. So that's going to be equal to 3 times 2 is 6, 5 times 4 is 20, and we just did that in a calculator a second ago. We know that's a 30% chance of that happening. All right, but that's not the only way that could happen, is it? You could also pull the green first, then pull the red. So it could happen that way as well. So we better figure out that one. So in that case, this would be the probability of getting a green first, multiplying that by the probability of getting a red, given that we had green on the first pick. So probability of getting a green is 2 out of 5. 2 out of 5. Times probability of now picking a red is there's still 3 red marbles because we took a green on the first one, but there's not 5 marbles left because we took a red one. There are 4 marbles left. And you'll notice, look at this, 3, it's going to give us the same answer, right? It's still going to be a 6 over 20, which equals a 30% chance. Now, because there's 2 ways it can happen, we need to take our answers and add them together. Okay, we have to add, we want to accumulate all the percentages of the different ways this could happen. So we want to add these together so you have a 60% chance of getting 2 different colored marbles if you make 2 picks. All right, so hopefully that explains and you got a good idea of how dependent events work. So right below this video on the page, you'll see your classwork. I believe it's something like questions 1 to 4 or something like that. Just check, it says right below. I'll have it there. So do the questions. Next week, little housekeeping. So end of video housekeeping here. Just a little couple of notes just so you know what's going on. Okay, next week I'm going to do some sort of short quiz, and I don't mean quiz as I don't mean let me write that down. I don't mean what Canvas refers to as a quiz, because you know your classworks, you know, Canvas doesn't have a thing for classwork. You have to call it a quiz. Okay, I don't mean a Canvas quiz. I mean an actual quiz. What I mean by that is an actual test grade quiz. Now you guys know that we usually do every unit. I usually do one like simplified quiz for you. It will be something like 5 to 10 questions. The difficulty will be lower than that of a test, but the nice thing is that it is going to go in as a test grade, which you know makes up 60% of your mark. So it's a chance for you to boost your grades, because I intend to make this so that you can do quite well on this 5 to 10 question little quiz. We'll be having that sometime next week, so watch for that next week. It'll be pretty heavy on the dependent events, but I might throw 1 or 2 questions in there from the stuff we did before. But it'll be pretty heavy on the independent and dependent things. Now, just so you know where we're at, after this week, we have 2 weeks. We have 2 weeks of classwork. Okay, and then we'll have 1 week at the end. 1 week will be review and unit test. Then we're done. So at the end of this week, we only have 3 weeks of school left. 2 weeks will be classwork type stuff, and then that final week will be review and the unit test. And just, I know you're aware of this because I told you about it in the other video, there is no final. So the last test that you write will be a unit test. There is no final because we're doing online at home. So there is no final test that you have to worry about. And we're getting close to the end. So hang in there, guys. We're almost done. I hope everyone's doing well. And don't forget to come talk to me in the mornings. I'm always on between 9 and 10 every morning. There's a lot of you that I don't hear from. So, I mean, stop in and say hi if you want to. I haven't seen a lot of you in forever. And this is kind of a crummy way to end the school year. So, all right. I hope you're doing well. Take care. Talk to you later. Bye.